Hello everyone, this is Ayush Singh, a student of Mechanical Engineering third year at Delhi Technological University, and I'm going to present the topic Morse test for mechanical efficiency of SI and CI engines. To begin with, I would like to explain what mechanical efficiency is. So, mechanical efficiency is the ratio of the brake power to the indicated power, and it depends upon multiple factors such as the engine design, the cooling conditions, the quality and quantity of lubrication used, and the overall accuracy of manufacturing of that engine. In the case of single cylinder engines, the brake power is measured from the conventional mechanical, hydraulic, or electrical dynamometer, and the indicated power is taken from the conventional indicator diagram, and hence the mechanical efficiency is derived from the ratio of the brake power to the indicated power. But in the case of multi-cylinder engines, the mechanical efficiency is taken by the help of Morse test. Morse test requires a dynamometer, a technometer, and a means of cutting off the cylinders, such as in the case of SI engines, we short circuit the spark plug, and in the case of CI engines, we cut off the fuel supply. Moving on to the procedure of the test, the first step is to measure the brake power at the time when all the cylinders are up and running. The next step is cutting off one cylinder from the system, and the next step is to measure the brake power once again of the remainder of the system. The basic fact at work here is that the indicated power is the sum of the brake power and the other frictional and pumping losses. So when one cylinder is cut off from the system, the total share of loss that is caused due to that one cylinder is now bared by the remaining system. So the overall decrease that is now observed at the dynamometer is that amount which should normally be bared by that cylinder. So the total reduction in amount in the indicated power is actually the indicated power of that cutoff cylinder. This can be explained by the help of an example. So consider A is the brake power with 6 cylinders firing and B is the brake power with 5 cylinders firing. I is the indicated power for one cylinder and L is the loss bared by one cylinder. Then A is equal to 6 into I minus L and B is equal to 5I minus 6L. Hence, the difference A minus B is equal to I, which is the indicated power for the cutout cylinder, which would be common in the case of any cylinder. So, by cutting out each cylinder, the indicated power for each of them can be calculated, and through addition we can calculate the indicated power for whole of the engine. The mechanical efficiency is now given by total brake power divided by the total indicated power. The mechanical efficiency also varies with the load and speed, and hence it must be maintained that the speed at which the engine is run must be maintained constant throughout the test. The Morse test can be plotted for different speeds, and the mechanical efficiency against the RPM is plotted in the next figure. Now, as you can see from the figure, the mechanical efficiency for constant brake power decreases with increasing RPM. The mechanical efficiency can also be plotted against the brake power, and in this case, the speed is not altered at all. Now, as you can see from the figure, for constant speed, the mechanical efficiency increases with the increase in brake power. So that was the Morse test for mechanical efficiency in SI and CI engines. Hope you liked the video.